We're going to cover section 2 of chapter 3. Today we're going to be using parallel lines and a transversal. So we're going to learn some theorems. Now, in our old book, the first one was called a postulate. So actually all of these are going to be theorems. None of them are postulates. So in our old textbook, they called the first one a postulate, but they're all theorems in our new book. So they're all going to start out with the same statement here, the same beginning. And they're all going to have, if parallel lines are cut by a transversal, then corresponding angles are congruent, and that's the corresponding angles theorem. Then again, the next one, if parallel lines are cut by a transversal, then alternate interior angles are congruent. And this one's called the alternate interior angles theorem. And then the next one, the alternate exterior angles theorem. This one again states, same beginning, if parallel lines are cut by a transversal, then alternate exterior angles are congruent. And the last one, which is different, is the consecutive interior angles theorem. Here, this one states that if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. So this is the only one that is not congruent. They're going to be supplements. We are going to be using these theorems as our reasons in the proofs that we're writing for chapter 3. So now that we have these 4 theorems, now we're just going to do examples applying these 4 theorems. So what we're going to need to do is look for the 2 parallel lines that are going to be cut by a transversal. And then we're going to have to identify what kind of angle pair we're looking at. And if they happen to be corresponding, alternate interior, alternate exterior, they're going to be congruent angle pairs. However, if they're consecutive interior, then they're going to be supplements. And this is what you're doing in the homework as well. So what you're going to be doing at the beginning, really all you're going to be doing is subtracting from 180 on a lot of the first questions. But then towards the end of the homework, you're going to be setting up algebraic equations to solve. And I need to see all of that work. So every question will have work in the homework tonight. Okay, so on the next slide, it wants us to find the measures of each angle. Now, what I sometimes do when it's a question like this, where I have to figure out the measure of every single angle, sometimes it's easier to fill in the picture versus trying to answer the questions in order. And that's what I'm going to do. I'm just going to zoom into the diagram. I'm going to fill in the diagram, and then I'll go back and answer the 8 questions. Now, in this particular picture, there's actually 2 transversals. Now, notice my parallel lines are located here and here because they have this arrow on them indicating that those are the parallel lines. Now, I have a transversal right here, which is created angles 1, 2, 3, 4, 5, 6, and 7. And then I have a second transversal over here. So this has 2 parallel lines. The red are the parallels, and then the gray lines that I just highlighted over are the transversals. Now, for the angle 8, that one's easy to see, and they've even given us the little box. But if you notice, this angle here is corresponding to angle 8. So even if it didn't have the little box around 8, you could recognize that they're corresponding angles. Notice they're in the same corresponding spot if you boxed it around. So angle 8 is 90 degrees. Now I'm going to go to the other side. And this is where I need to use that 130 that's there. And I know it shifted a little, but the 130 is right here. So what I'm going to do now is I need to figure out some special angle pairs that are going on here. Now, you can use not only the special angle pairs we just talked about, you can also use your vertical angles theorem, and you can also use your linear pair postulate. So without even using my chapter 3 information, I could figure out the value of these 3 missing angles just by using my prior knowledge. So for angle 7, it's going to be vertical. Angle 7 should be here. Angle 6 is this one, and it's vertical. Then angle 5 with the 130 is a linear pair. So what I can do here is subtract 180 minus 130, and angle 5 is 50, which is vertical to angle 7. So I've just answered 3 of the questions without even using any of the knowledge from chapter 3. Now, to connect it to angles 1, 2, 3, and 4, this is where I need to bring in chapter 3. So notice this is my interior portion. Let me go ahead and highlight it. So in between the 2 red lines, this is my interior part. So I can see that angle 3 and the 130 are alternate interior angles. So that would make angle 3 130 degrees. Then you can look at the same angle 4 and angle 5 are also alternate interior. So then that would make angle 4 50 degrees. Now, we could use our vertical angles to fill in angles 1 and 2. But let's use some of our chapter 3 knowledge. And you can see that angle 1 and angle 7 are alternate exterior angles. So angle 1 would be 50. And then angle 2 is alternate exterior to 6, so it would be 130. Once you're given one angle out of the 8, you can find the other 7 by either using vertical angles, linear pair postulate, or any of the 4 theorems we just learned. The alternate interior angles theorem, alternate exterior angles theorem, corresponding angles theorem, or the consecutive interior angles theorem. Remember, the first 3 that I just said are all make them congruent, but the only one that are going to be supplements are going to be the same side interior, or also called consecutive interior. And if you look at it, you could check it. Notice 4 and the 130 here, when you add them, they equal 180. Those are same side interior or consecutive interior. Once you fill in the picture, you're only going to see 2 numbers keep repeating. That's all that's going to be in that picture when you have 2 parallel lines and a transversal. Unless it's a 90-degree angle, then they're all 90. So let me go ahead and fill in the answers now. So angle 1 is 50. Angle 3 is 130. Angle 5 is 50. Angle 7 is 50. Angle 2 is 130. Angle 4 is 50. And angle 6 is 130. So sometimes it's easier to fill in the diagram if they're asking you to find multiple angles from the same picture. Now you could take it one at a time. If we would have done that, there is no relationship between angle 1 and the 130. We would have first maybe either needed to have found angle 2, which would have been corresponding, or angle 3, which was alternate interior. And then I could have subtracted from 180. Okay, so for here, it says find the missing values. Again, I've got my parallel lines here. They've got the arrows on them. And again, I have 2 transversals. This is my first one and my second one. Actually, these are parallel as well. You see the tiny arrow there? Now, this will be the scenario where you might want to ignore part of the picture and only look at what you need to look at. Now, in my picture here, I could work with this left side. So like I could ignore this and just work with that one side. And then sometimes you're gonna have to fill in other angles in order to maybe solve the problem. So for this one, I'm gonna go ahead and I guess we can still do it in order. Let's do X. So notice X, these are my parallel lines, the gray ones. And in this problem, even though the red one here is parallel to this one, it's also a transversal for the gray. So X and 110, these two are consecutive interior. So what I would need to do is, if you wanted to set it up algebraically, you would do X plus 110 equals 180. And then really all you're doing is subtracting it from 180, and the missing angle there for X is 70 degrees. So X is 70. Now for Y, now we're referring to the two red lines as being the parallel, and the gray is the transversal. So if it helps you to ignore this, these two, again, if you box them, are corresponding. And I just found the value of X at 70. And remember, corresponding angles, these are both in the same corresponding position, they're congruent. So I'm going to set up my algebraic equation as 2y equals 70, divide by 2, and y is 35. Because when you plug it back in, you would get 70 degrees. Now, for Z, let me see if I can erase this blue that I scribbled. Now, to find Z, I can do two things here. I can either realize that these two are same side interior, 2y and 2z, or I could use the fact that 110 and 2z are corresponding because they're both in the same corresponding spot. So that's what I'll do here, is I'm going to use the fact that these are corresponding. So I'm going to set 2z equal to 110, divide by 2, and z equals 55 degrees. Actually, z is just 55. Once we times it by 2, then it's 110. So z equals 55. You could put the degree symbol. It's fine on all these. Okay. Doing these, you may have to cover up part of the picture. You may have to rotate your iPad. When you take the quiz next week, you may have to turn your paper around in order to see it. Let's try example 3. It's going to be a real world problem. So here it says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 equals 40 degrees. They want us to find the measure of angle 1. And how do we know that? So let me go ahead and maybe trace over this. So we've got this yellow line here. And notice it's got the little arrow on it indicating it's parallel to this one. And then, so those are my parallels. And then I have my transversal here. And it's created angles 2 and angle 1. Notice these are alternate interior angles, and I know that alternate interior angles are congruent. So if angle 2 is 40 degrees, so is angle 1. So your explanation is because you're using the alternate interior angles theorem, which tells me that the angles are congruent. So angle 1 equals 40 degrees. Whenever I give you a homework problem and it's asking you to drag and drop into the proof, I still want to see you try to write it out on your Notability or on your paper, because that's what you're going to eventually be doing on your test. You're going to be writing your own proof. You're not going to have stuff to drag and drop on a test or even a word bank. So I always want to try you to write it out, and then once you get it written out, then you can go to your big ideas and drag and drop. All right, so let's go ahead and set up our two columns. We have our statement column and our reasons. So my first statement is what was given to me. P is parallel to Q. And notice it is marked on my picture. It's got those little red arrows. So this is given. Now what we can do is look for some special angle pairs. So because I'm told that I have parallel lines, I could state here that angle 1 is congruent to angle 3, and my reason is the corresponding angles theorem. The next thing I can tell in my picture is that I have angle 2, which is congruent to angle 3. And that reason is the vertical angles congruence theorem. And I'm going to abbreviate that as VAT. So I can state that angle 3 is congruent to angle 2 because they're vertical angles. Now what I can do is notice this angle 3 and angle 3 overlap. So now I can conclude what I was trying to prove, that angle 1 is congruent to angle 2, and my reason is transitive, or in this case, substitution. Now remember, sometimes when it's substitution only, you can't use transitive. But if it's transitive, then you could have also said substitution. So substitution doesn't always go with transitive, but transitive always goes with substitution. Yes?
Could you also use alternate interior angles theorem?
So, yep, so that's what I'm going to tell you now. So this was just the proof of the theorem, but now that you've been taught the theorem, what he just said was perfectly true. Because we now know the theorem, we could have solved this question in 2 steps. So we could have done our statements and our reasons. And without having to go through all that, just state that if P is parallel to Q, which was given, then we can use that alternate interior angles theorem and just go right to the statement. Angle 1 is congruent to angle 2, and the reason is the alternate interior angles theorem. And if you want to abbreviate it like that, or you can spell out all those words, but I could put ALT for alternate interior. I could put INT and then the little symbol for angles and then theorem. And you can do it in 2 steps because you've been taught the theorem. But if they had ever asked you to write the theorem, the proof of the theorem, then you would have had to do it in those 4 steps because you couldn't have used the alternate interior angles theorem yet because you were proving it first. So that is it for the notes on section 2. Again, remember, every question has work for the 3-2 homework. So you can go ahead and get started on it. You do have quite a bit of time, around 15 minutes here to get started. And then that way, if you're stuck on any problems, you can come and ask.